Things like Enter Sandman during a Virginia Tech game causes ground shaking that can be measured with a seismograph. And so that would be considered an earthquake by that definition. My name's Matt Eatherton. My field of research is related to how buildings behave during earthquakes and how to design them to better perform and be resilient after earthquakes. Perhaps the most complete or best way to test buildings is to put them on a shake table, which is a platform that reproduces the motion of the ground during an earthquake. In reality, there's very few shake tables in the world that can do that with full-size buildings. So often we take parts of buildings, components of buildings, like say a beam-to-column connection, and we'll test those in the lab and we'll subject them to cyclic loading. And once we characterize their behavior, we can put all those pieces together in a computational model, and we can subject that model to the same ground motions that the building would experience during an earthquake. There is no such thing as an earthquake-proof house. So we talk in terms of probability. The building codes are calibrated to produce a 1% probability of collapse in 50 years. The way earthquakes are typically measured, historically, we've used something called the Richter scale. More modern magnitude scales are things like the moment magnitude scale, which measures the amount of energy released. Regardless of the scale, these are log-based scales, which means that when we say a magnitude 6 earthquake, that's actually 10 times larger than a magnitude 5. And similarly, magnitude 7 is 100 times larger than a 5. Earthquakes do happen in Virginia. In 2011, there was a magnitude 5.8 earthquake in Louisa County. It could be felt as far away as Canada. We're in the middle of the North American plate, and because of that, earthquakes can travel a lot farther. It's analogous to a bell. If you ring a bell that's cracked, kind of like the crust on the West Coast is cracked, it's kind of a dull thud and the vibrations damp out quickly. On the East Coast here, when there's an earthquake and you ring that bell, there's no crack and it rings for a long time and loudly. A building could be very flexible, but if it is, during a windstorm, the house is going to sway back and forth and it's not a good solution. So the way we design buildings to resist earthquake is with something called ductility. And a good way to think about ductility is with a paper clip. You can bend a paper clip back and forth and it continues to resist that bending without breaking. That's what we want our buildings to do, be able to bend without breaking. If you are in a building during an earthquake, you want to be away from windows, you want to be away from things that could fall on you. Usually there's not a lot of time to think about it. Many of the injuries during earthquakes are due to falling contents. So getting under a table or a desk is the best way to protect yourself. My name's Matt Eatherton. I'm a professor in civil and environmental engineering here at Virginia Tech.